Network security attacks, layer-wise attacks in wireless sensor networks that includes physical layer attacks, data link layer attacks, network layer attacks, transport layer attacks, and application layer attacks. Network security attacks. Wireless networks are vulnerable to security attacks due to the broadcast nature of the transmission medium. Furthermore, WSN have an additional vulnerability because nodes are often placed in a hostile or dangerous environment where they are not physically protected. For a large-scale sensor network, it is impractical to monitor and protect each individual sensor from physical or logical attack. Attackers may devise different types of security attacks to make the wireless sensor system unstable. Network security attacks are classified on the basis of capability of attacker, attacks on information in transit, host-based versus network-based attack. Based on capability of the attacker is furthermore classified into outsider versus insider attacks, passive versus active attacks, mode class versus laptop class attack. Attacks on information in transit are furthermore classified into interpretation, interruption, interception, modification, fabrication, replaying existing messages. Host-based versus network-based attacks are also discussed. Based on the capability of the attacker, it is classified into outsider versus insider or node compromise attack. The outsider attacks are defined as attacks from nodes which do not belong to a wireless sensor network. Insider attacks occur when legitimate nodes of a WSN behave in unintended or unauthorized way. Passive versus active attack. Passive attacks include eavesdropping on or monitoring packets exchange within a wireless sensor network, whereas active attacks involve some modification of the data stream or the creation of a false stream. Mode class versus laptop class attacks. In mode class attack, an adversary attacks a wireless sensor network by using a few nodes with similar capabilities to the network nodes, whereas in laptop class attacks, an adversary can use more powerful devices, for example a laptop, to attack a wireless sensor network. These devices have greater transmission range, processing power, and energy reserves than the network nodes. Attacks on information in transit. In a sensor network, sensor monitor the changes of specific parameters or values and report to the sink according to the requirement. While sending the report, the information in transit may be attacked to provide wrong information to the base station or the sink. The attacks are interruption, interception, modification, fabrication, replaying existing messages. Interruption. Communication link in sensor networks become lost or unavailable. This operation threatens service availability. The main purpose is to launch denial of service (DOS) attack. From the layer specific perspective, this is aimed at all layers. Interception. Sensor networks have been compromised by an adversary where the attacker gains unauthorized access to the sensor node or data in it. Example of this type of attack is node capture attack. This threatens message confidentiality. The main purpose is to eavesdrop on the information carried in the message. Modification. Unauthorized party not only accesses the data but also tampers with it. This threatens message integrity. The main purpose is to confuse or mislead the parties involved in the communication protocol. This is usually aimed at the network layer and the application layer because of the richer schematics of these layers. Fabrication. An adversary injects false data and compromises the trustworthiness of information. This threatens message authenticity. The main purpose is to confuse or mislead the parties involved in the communication protocol. This operation can also facilitate DOS attack, denial of service, by flooding the network. The last is replaying existing messages. This operation threatens message freshness. The main purpose of this operation is to confuse or mislead the parties involved in the communication protocol, that is, not time aware. Host-based versus network-based attack. Host-based attack. It is further broken down into user compromise. This involves compromising the user of wireless sensor network, for example, by cheating the users into revealing information such as password or keys about the sensor node. Hardware compromise. This involves tampering with the hardware to extract the program code, data, and keys stored within a sensor node. The attacker might also attempt to load its program in the compromised node. Software compromise. This involves breaking the software running on the sensor nodes. Chances are the operating system and the application running in the sensor nodes are vulnerable to popular exploits such as buffer overflows. Network-based attacks. It has two orthogonal perspectives: layer-specific compromises and protocol-specific compromises. This includes all the attacks on information in transit. Apart from that, it also includes deviating from protocol when the attacker is or becomes an insider of the network. The attacker's purpose is not to threaten the service availability, message confidentiality, integrity, and authenticity of the network, but to gain an unfair advantage of itself in the usage of network. The attacker manifests selfish behavior that deviates from intended functioning of the protocol. Layer-wise attacks in WSN. This discusses about the wireless sensor network layer-wise attack. Physical layer attacks. Jamming. This is one of the denial of service attack in which the adversary attempts to disrupt the operation of the network by broadcasting a high energy signal. Jamming attack in WSN, classifying them as constant, that is corrupt packets as they are transmitted. Deceptive sends a constant stream of bytes into the network to make it look like a legitimate traffic. Randomly alternates between sleep and jamming to save energy. And reactive, that is, transmits a jam signal when it senses traffic. Therefore, they are classified into constant, deceptive, random, and reactive. To defend against these attacks, use spectrum techniques for radio communication. Handling jamming over the MAC layer requires admission control mechanism. The second is radio interference. Here, adversary either produces large amounts of interferences intermittently or persistently. To handle this issue, use of symmetric key algorithm in which the disclosure of the key is delayed by some time interval. The last is the tampering or destruction. Given physical access to a node, an attacker can extract sensitive information such as cryptographic keys or other data on the node. One defense to this attack involves tamper-proofing the node's physical package. Self-destructive, that is tamper-proofing package, whenever somebody accesses the sensor nodes physically, the nodes vaporize their memory contents and this prevents any leakage of information. Data link layer attack. It includes continuous channel access, collision, and fairness interrogation Sybil attack. Continuous channel access, that is exhaustion. A malicious node disrupts the media access control protocol by continuously requesting or transmitting over the channel. This eventually leads a starvation of the other nodes in the network with respect to channel access. On the countermeasures to such an attack is rate limiting to the MAC admission control such that the network can ignore excessive requests, thus preventing the energy drain caused by repeated transmission. A second technique is to use time division multiplexing, where each node is allotted a time slot in which it can transmit. Collision. This is very much similar to the continuous channel attack. A collision occurs when two nodes attempt to transmit on the same frequency simultaneously. When packets collide, a change will likely occur in the data portion, causing a checksum mismatch at the receiving end. The packet will then be discarded as invalid. A typical defense against collision is the use of error correcting codes. Unfairness. Repeated application of these exhaustion or collision based MAC protocol layer or an abusive use of cooperative MAC layer priority mechanism can lead to unfairness. This kind of attack is a partial DOS attack but results in marginal performance degradation. One major defensive measure against such attack is the usage of small frames so that any individual node seizes the channel for a smaller duration only. Interrogation. This exploits the two-way request to send or clear to send RTS-CTS handshake that many MAC protocols use to mitigate the hidden node problem. An attacker can exhaust a node's resources by repeated sending RTS messages to elicit CTS responses from a targeted neighbor node. To put a defense against such type of attack, a node can limit itself in accepting connections from same identity or use anti-reply protection and strong link layer authentication. The last is the Sybil attack. In this attack, a single node presents multiple identities to all other nodes in the wireless sensor network. This may mislead other nodes and hence routes believed to be disjoint with respect to the nodes can have the same adversary node. A countermeasure to Sybil attack is by using a unique shared symmetric key for each node with the base station. Network layer attacks. This includes sinkhole attack, hello flood, node capture, selective forwarding or black hole attack, wormhole attack, spoofed, misdirection, homing. Sinkhole attack. Sinkhole attack normally occurs when compromised node sends fake routing information to other nodes in the network with aim of attracting as many traffic as possible. Hello flood. This attack exploits hello packet that are required in many protocols to announce nodes to their neighbors. A node receiving such packet may assume that it is in radio range of sender. A laptop class adversary can send this kind of attack to all sensor nodes in the network so that they believe the compromised nodes belong to their neighbor. This causes a large number of nodes sending packets to this imaginary neighbor and thus into oblivion. Authentication is the key solution to such attack. Such attacks can easily be avoided by verify bidirectionality of a link before taking action based on information received over that link. Node capture. Node capture attack is a serious attack through which an intruder can perform various operations on the network and can easily compromise the entire network. It is one of the hazardous attacks in WSN. A single node capture is sufficient for an attacker to take over the entire network. Selective forwarding black hole attack. In black hole attack, a malicious node falsely advertises good path, that is shortest path or most stable path to the destination node during the pathfinding process or in the route update message. The intention of the malicious node could be to hinder the pathfinding process or to intercept all the data packets being sent to the destination node concerned. Malicious or attacking nodes can, however, refuse to route certain messages and drop them. If they drop all the packets through them, then it is called black hole attack. However, if they selectively forward the packet, then it is called selectively forwarding. To overcome this, multi-path routing can be used in combination with random selection of paths to destination, or braided paths can be used, which represents paths which have no common link or which do not have two consecutive common nodes or use implicit acknowledgement, which ensures the packets are forwarded as they are sent. Wormhole attack. An adversary can channel messages received in one part of the network over a low latency link and reply them in another part of the network. This is usually done with the coordination of two adversary nodes, where the nodes try to understand their distance from each other by broadcasting packets along an out-of-bound channel available only by the attacker. Spoof, altered, or replayed routing information. The most direct attack against a routing protocol in any network is to target the routing information itself while it is being exchanged between nodes. An attacker may spoof, alter, or replay routing information in order to disrupt traffic in the network. These disruptions include the creation of routing loops, attracting or repelling network traffic from select nodes, extending or shortening source route, generating fake error message, partitioning the network, and increasing end-to-end latency. Misdirection. This is a more active attack in which a malicious node present in the routing path can send the packet in wrong direction through which the destination is unreachable. In place of sending the packet in correct direction, the attacker misdirects those and that too forwards one node, and thus this node may be victimized. Homing. In a homing attack, the attacker looks at the network traffic to deduce the geographic location of critical nodes, such as cluster head or neighbors of the base station. The attacker can then physically disable these nodes. This leads to another type of black hole attack. Transport layer protocol, flooding and desynchronization attack. Sometimes the malicious node can cause immense traffic of useless messages on the network. This is known as flooding. Sometimes malicious node replies some actual broadcast messages and hence generating useless traffic on the network. This causes congestion and may eventually lead to the exhaustion of complete nodes. This is a form of denial of service attack. Desynchronization attack. In this attack, An adversary repeatedly forges messages to one or both ends with request transmission of missed frames. Hence, these messages are again transmitted, and if the adversary maintains a proper timing, it can prevent the endpoint from exchanging any useful information. Application layer attack that includes overwhelm attack, path-based DOS attack, deludge, reprogram attack. Overwhelm attack. An attacker might attempt to overwhelm network nodes with sensor stimuli, causing the network to forward large volumes of traffic to a base station. This attack consumes network bandwidth and drains node energy. Path-based DOS attack. It involves injecting spurious or replayed packets into the network at leaf node. Reprogram attack. Network programming system lets you remotely program nodes in deployment network. If a reprogramming process is insecure, an intruder can hijack this process and take control of large portion of network. It can cause authentication stream to secure reprogramming process. So these are the various attacks